Hello everyone, welcome back to this channel again. Today through this video I'll try to make you understand concepts related to frustum. So let's see. I repeat, concepts related to frustum. So as we all know, frustum is a part of a cone, right? It is generally, I'm just making one. This is a frustum. You can take it as a joker's cap or some glass or a tub, right? So which is given in the shape of frustum. In this frustum, friends, from here to here, this is, let's take R1, and this is from here to here, this is R2, this is H, and this is L. I repeat, R1 is the radius of its this face, circular face. R2 is the radius of this second bottom circular face. H is the perpendicular height and L is the slant height. As I said, this frustum is derived from the cone. So to understand its C.S.A, T.S.A and volume, we will use the cone concepts. So to make you understand, I'm just extending this side, right, and extending this side as well, so that we can obtain exact cone, right? This portion from here to here, this is capital L, and this from here to here, let's take, just to make you understand, I'm writing this way from perpendicular height, this is H, right? The R is already clear. So for the upper part, when I talk about this part, let's label this as O, A, B, C, D. These are perpendiculars. So from ODA, from the figure, I'll write some general information. AD, as I said, it's R1, right? BC is R2, DC is small l, right? OC is capital L, AB is small h, OB is capital H, right? So to make you understand, before I start the actual derivation, OD's value will be what? So OD will become, I repeat, this total O to C is L, capital L, and D to C is small l. So OD is nothing but that is capital L minus small l. I hope this is clear. And when I talk about OA, for OA, let's understand, O to B is capital H, right? E to B is small h, therefore OA value is capital H minus H. I hope this is clear, right? Going ahead, as I said, first we are discussing, these are the general things, right? So I'll prove triangle OAD and triangle OBC similar. I repeat, we'll prove triangle OAD and triangle OBC similar. So I'm writing in triangle OAD and triangle OBC. First thing, angle OAD equals to angle OBC. And we all know the reason. Reason is each of 90 degree. Hope this is clear. Second angle, angle AOD equals to angle BOC, which is nothing but, we can say it is common angle. right? As we got two pair of angles, so therefore triangle OAD is similar to triangle OBC. Hope this is clear, and this is by a test of similarity. As these two triangles are similar, therefore their sides are in proportion. So we can write OA upon OB equals to AD upon BC equals to OD upon OC, right? Corresponding sides of similar triangle. We can write here corresponding sides of similar triangle. I hope this is clear. For this step, just we will substitute all the values. OA value is what from here? Capital H minus H. Upon OB value is what? OB is capital H, right? Equals to AD value is what? R1. BC value is what? R2. OD value is what? L minus L. OC value is what? Capital L. Hope this is clear to you all. This is the most important step which we are going to use. We have proved the triangle similar, then we have written their sides in proportion, and then just we are writing these expressions. I hope this is clear. So from here, from expression 1, we will try to get the value of capital H and capital L, as these things are not required, in the form of small h and R1 and R2. So first I am taking H minus H upon H equals to R1 upon R2, which can be written as H minus H equals to, here I can write it as R2 into this. This can be written as R1H. So when you will see this, friends, R2H minus R2 small h equals to R1 capital H. We need to make it as a subject of capital H. So this step can be written as further I'll explain, don't worry. So this step further can be written as, I was talking about this step, right? So from here I'm taking this h to this side, this R2H to that side. So this can be written as R2H minus R1H, right, equals to R2 small h. I repeat, I just took this R1H to this side and this R2 small h to that side. So from here, when you see this, we can take capital H common. So when your capital H is common, we are getting R2 minus R1 in the bracket equals to R2H. So the value of capital H is what, friends? R2H upon R2 minus R1. I hope this is clear. So let's label this as 2. We got the value of H. Then same way I'm trying to find out the value of capital L. So that is R1 upon R2 equals to L minus L upon capital L. So this is R1 capital L equals to R2 capital L minus R2 small l. I have just cross multiplied. So this will become R1 capital L, right, minus R2 capital L equals to minus R2 small l. This can be written as RL common R1 minus R2 equals to minus R2 L. Further it can be written as L equals to minus R2 L upon R1 minus R2. If we want to eliminate this minus sign, this can be written as R2L upon R2 minus R1. Let's label this as 3. Now coming back to very important thing. Once you have understood this thing, it becomes very simple, right? So when we were talking about C.S.A, right? Purposely I'll be taking C.S.A to the new page so that I can make you understand, right? So friends, here I was talking about this figure. I hope this is clear to you all, right? So C.S.A of this one, right? C.S.A of this part will be total C.S.A of cone minus C.S.A of this smaller cone. I repeat, C.S.A of this first term is C.S.A of the bigger cone minus C.S.A of the smaller part. That means when I'm taking C.S.A, now after this C.S.A of first term, I repeat, C.S.A of bigger cone minus C.S.A of smaller cone. So what is C.S.A of bigger cone? C.S.A of bigger cone is pi. I'll repeat from this figure, right? I hope you all can see. C.S.A of bigger cone is pi, right? Radius is R2 and slant height is capital L. So pi, radius is R2, slant height is capital L. Minus, what is C.S.A of the smaller cone? C.S.A of the smaller cone is again pi, radius is R1 and slant height means this OD, and OD was what? L minus L. That means pi R1 instead of L, it will become L minus L. I hope this is clear. So this will become pi R2L minus pi R1 capital L. This minus and minus will give us plus. We'll get pi R1L. So from the first two, we can take pi and capital L common. So in the bracket we have R2 minus R1 plus pi R1L. So already when you say here, we have value of L which we have calculated. So what is the value of L? Value of capital L is R2 into small l upon R2 minus R1. That means this can be written as pi. I repeat, what is the value of capital L? The value of capital L is R2 into small l upon R2 minus R1 into this R2 minus R1. Hope this is clear. Plus pi R1L. So this R2 minus R1 gets cancelled with this. What is remaining here, friends? Pi R2L plus pi R1L. From this can be written as pi R1 plus R2L. So friend, this is derivation for C.S.A of Frustum. Hope it is clear to you all. Now we will discuss about T.S.A of Frustum. So T.S.A of Frustum is nothing but it's C.S.A plus area of this circle, top circle, plus area of its bottom circle. That means, so the T.S.A will become, I repeat, pi R1 plus R2L plus area of the top circle, that is pi R1L, plus area of the pi r1 square plus pi r2 square. I hope this is clear. So from this, the final formula for T.S.A can be taken as pi common. So r1 plus r2 in bracket L plus r1 square plus r2 square. I hope this is clear to you all. So we have discussed here C.S.A of Frustum and we have discussed here T.S.A of Frustum. Going ahead with the last concept related to frustum is the cone of this frustum. Same way its volume will be, volume of this frustum, not cone of the frustum, right? Volume of this frustum will be what? Volume of the bigger cone minus volume of the smaller cone. So same way, so when I'm talking about volume of frustum, that will become volume of bigger cone minus volume of smaller cone. So volume of bigger cone is what? Already we know that the volume of cone is what? 1 upon 3 pi r square h. So the volume of bigger cone will be 1 upon 3 pi r square h. So for the bigger cone, radius is r2 square and the h will be capital H. I hope this is clear. Minus volume of the smaller cone will be what? 1 upon 3 pi r1 square. And for the smaller cone, let's understand. For the smaller cone, the height is OA. OA means h minus h, so which can be written as 1 upon 3 r1 square. Instead of height, what we'll write? Capital H minus smaller h. So from this to what we can do? We can just expand this. This can be written as 1 upon 3 pi, right? And then this can be taken as common. So inside what you have? Inside you have r2h minus r1 square h minus h. Hope this is clear. So after this, 1 upon 3 pi, try to understand, r square capital H minus r1 square capital H, minus into minus will give us plus r1 square h. Now our job is to replace this capital H. So this will become 1 upon 3 pi, right? So this capital H is common. In bracket you have r2 square minus r1 square plus r1 square h. So friends, already we have done derivation. If you remember from the previous step, we got this, and here is the value of h. What is the value of h? r2 into h upon r2 minus r1. So this will become 1 upon 3 pi. Value of h is r2h upon r2 minus r1 into, this can be written as a square minus b square means a plus b into a minus b plus r1 square h. Hope this is clear. So this r2 minus r1 is cancelled out. So after this, I'm writing here so that you can get it easily. So 1 upon 3 pi is already there. In bracket now you have r2h, right? So this is r2h. In bracket you have r2 plus r1, and this is r1 square h. Hope this is clear to you all. So from here you can take 1 upon 3 pi. You can take h common. When you're taking h common, what is remaining inside? This r2 into r2 can be written as r2 square, plus this can be written as r1 into r2. H already gone out, so what is remaining? r1 square. So final formula for volume of frustum is 1 upon 3 pi h in bracket r1 square plus r2 square plus r1 into r2. Hope this is clear to you all. So let's quickly revise what we have done today. We have understood the three basic formulas related to frustum, where frustum is derived from cone, right? So this part is frustum, right? And so we have extended its sides to get the bigger cone. We have written different values of its sides, right? We have proved this triangle OED and OBC similar, right? We got their sides in proportion. From that we substituted the values. We have calculated value of capital H and capital L, and then we started for C.S.A of frustum. So C.S.A of frustum is C.S.A of bigger cone minus C.S.A of smaller cone. We substitute the value we have calculated, and final answer for C.S.A of cone frustum is pi r1 plus r2 L. Similarly, T.S.A of frustum will be C.S.A plus area of top circle pi r1 square plus area of bottom circle, that is pi r2 square. So this is the formula for T.S.A of frustum. Then for volume of frustum, volume of bigger cone minus volume of smaller cone, substituted values, manipulated, and final formula is 1/3 of pi h in bracket r1 square plus r2 square plus r1 into r2. So friends, this is a very important derivation, right? C.S.A of frustum of a cone and volume of a frustum of a cone. This is very useful in 10th standard, right, in CBSE. And this is also these are the derivations from the optional exercise of surface area and volume chapter in NCERT. Hope you have understood, right? You will like this video and you will share it with your friends. Thank you so much everyone. Thank you so much for watching this.